Hey guys, Chris from DotProduct here, checking in from our Boston office. Today we're going to be demonstrating the new location service capabilities available to you in Dot3D 6.0 and up across iOS, Android, and Windows platforms that have GPS capabilities. This technology allows you to scan freely in an outdoor space to the accuracy of your local device's GPS, and then pop your 3D scan right into the right location on planet Earth in whatever software you're operating in from outside Dot3D. So to do so today, we're going to take you right outside our office door here into the courtyard of our Boston headquarters for a 3D scan of the space. Follow me. All right, so here we are on the other side of my iPhone, just outside the office. Before I start my scan, I want to make sure I turn on iOS location services from my Settings tab. I go to Settings, GNSS and Geo Settings, and turn on iOS location service, and you will see that satellite icon added to your new scan button. Now we're going to go ahead and start our scan. Of course, as always, we will be starting at an April tag. In this case, we kept it extra simple, and we just have one April tag to start and finish our quick sample scan at. So you see now I have this live read of my GPS, and you can toggle that on and off by tapping the top left button, and then press Start Mapping to begin your scan. As always, we'll turn our first April tag orange and finish back at it at the end of our scan.
So we'll spare you the 5 minutes of walking here today, but this was a simple scan back and forth across our courtyard, capturing the patio area and a little bit of the walls on either side until we finish up right here back at the April tag we started at.
And just like that, we have our initial unoptimized preview of the space we walked around very quickly here. Looking pretty good already, but let's go ahead and clean it up in optimization.
And as usual, we'll leave the optimization settings on their auto-selected defaults and let it process.
And boom, just like that, we've gotten through to our final result and are ready to move forward with this data. You'll notice that the data set has been completely cleaned up. Any sort of blurriness, misalignment, imperfections, incorrect overlap has completely been accounted for and adjusted, and we can go ahead and move forward with this scan in the optimized format. Let's say in this case we want to just work with the picnic table area here and leave out the rest of this courtyard scan. I'll go to my Edit Crop tab, select the area that I want to keep, which will be the picnic table area. We'll leave some of the border here as a best practice. Then invert and take out everything in red. Now we're left just with this picnic table section, and we're going to go ahead and move forward with that. So before we export, I'll quickly show you the new tab you have here called GNSS that will show the trajectory that was tracked while scanning. You'll notice some of these accuracies are pretty far off. Of course, this is because we're relying solely on the iPhone's GPS. Also, some of them might have been under the building, under a tree, under cloud cover, etc. But you can still get an idea of the back and forth trajectory that was taken while scanning. You don't actually have to do anything with this tab in the case of utilizing your phone's internal GPS. If you were instead utilizing a high accuracy GNSS like the Trimble DA2 or the Leica FLX 100 Plus, then you would visit this tab before optimization as prompted to fit your high accuracy GNSS to the optimization as an additional constraint. In our case here, I'm just showing this for your information. You don't actually have to go to this tab at all, as this is not being utilized for optimization, but it is being utilized as a new export option. So to go ahead and export your data to this new coordinate system, you want to go to File, Save As, and we'll call this GPS Test 1. Okay. Save it into our Dot3D data folder, and check this new option that's granted to you for GNSS. We'll go ahead and leave it in its default UTM coordinate system here in the greater Boston area and press Save Scene. Now, depending where we're going with the data, saving to DP might be all we need to do. But in this case, we're going into QGIS, which as of today requires a different file format for import of the point cloud. So we're going to follow that same procedure as we did for Save As, but do it for export. Save to an LAS file. Make sure the units are set to meters, the output transform is set to GNSS, and export the scene. Now, before we switch over to the computer to import this data into QGIS, we have one more feature to show here that'll help you understand what's happening in terms of the translation of this data set onto planet Earth. If I go to my menu, View, I now have a new option to view a map of the scan. And here you see the area that I scanned in highlighted in red, showing my full trajectory on this map of planet Earth. Now let's go ahead and switch over to our computer screen to import this data into our global application.
So here we are now inside QGIS, in particular the left side of a QGIS window, as we are now operating in a Windows desktop application. So we will move you around to fit the form factor of this video. You'll notice that I've opened up OpenStreetMaps in this powerful open source mapping software that we're using as an example today, again called QGIS. And to bring in my LAS file exported from Dot3D is as simple as a drag and drop into this window, and then you wait while it loads. Depending on your file size, this might take a few minutes to load in. If it's taking too long, however, or you run into any issues, please just simply try dragging and dropping it in again a second time. At that point, it should pop in instantaneously. And there we have it. Our dense Dot3D color point cloud has been auto-referenced to real-world coordinates and pops right into place on a map of the world. Here we see the courtyard back section of our Boston office, where the patio section is popping right into place where it should be on this map. In our testing so far, we've been remarkably impressed with how accurately the iPhone location GPS services alone can automatically position your Dot3D scan data in the right orientation and location on planet Earth. This is referenced into the 3D data itself and can carry through into a wide variety of GIS applications in any of the Dot3D standard export formats such as DP, E57, LAS, LAZ, etc. We encourage you to download Dot3D for iOS, Android, or Windows and give this new feature a try today using your built-in GPS functionality.